All right, as promised, we're going to take a closer look at disjunction and conjunction. I realize that your paper may not or does not have this color on it, so you may want to add some of this color in so you can see what it is that a disjunction looks like and a conjunction looks like. You can see that the point above the horizontal line is going to be your disjunction because there's two separate solution sets, and the points below the horizontal line are your conjunction because there is actually a single converging solution set. The next thing you want to address here is the way that you would take a look at inequalities in order to create conjunctions or disjunctions. Now the thing we're going to use here is we're going to use a little bit of a trick with our words. Which inequality makes a conjunction, and that's going to be the less than. Okay, so we can do less than, but instead of writing and, we're going to capitalize it as A and D. And that that type of mnemonic might help you out. A less than is going to be an and statement. And in this one, it's going to be greater. So if we rewrite it as great, but instead of ER, making it an OR statement, that might be helpful for you as far as looking at remembering these things a little bit easier. The next thing I want to talk to you about is an observation point that you guys want to be able to get good enough to see, because if you can see this, it will make a lot of your problem solving a little bit more easy. The solution to a following inequality when you have the absolute value of x plus 2 being greater than a negative number. The answer to that is all real numbers, because an absolute value function is always greater than a negative number. That's by definition. Absolute values cannot be negative. What is the solution to this following inequality? An absolute value of x plus 2 is less than negative 2. And the answer to that question would be no solution, because an absolute value can never be less than a negative solution. So just keep that in mind moving forward, and you want to be observant to that fact so that you can point that out and save yourself some steps in the algebra. And I'll point that out again when we go through these steps here. So notice what I was saying before, less than and greater than, okay? So it might help you if you can see that, but it has to be done only when the absolute value is on the left side and it has been isolated. So it can't be something that you notice right off the bat. It's got to be after a little bit of work has been done. So the first thing you want to do is isolate the absolute value. The second thing you want to do is, by using this observation up here, you want to determine conjunction or disjunction. Based on that, you will be able to go down to step number 5 to actually give your solution set. It's at this step, however, that you want to observe that the solution is negative, because of what I was talking about just a moment ago. Absolute value is always greater than a negative number and never less than 1. So that might help you save some steps here if you observe that moving forward. You're going to make two inequality statements, which is just like we did yesterday with the equations. You're going to solve each inequality. But please remember, when you write the negative solutions inequality statement, you actually have to switch the symbol. So keep that in mind so that you don't mess up any of your work. The next thing you're going to want to do is you're going to want to rewrite the solution set based on what we determined in step number 2. So we'll use this as our practice, and we're going to go ahead and rewrite this as 3 plus 2x is greater than or equal to 13. It's at this step that I'm going to observe the OR statement, okay? And that's greater. I'm also going to observe that this solution is positive. Since it is positive, I'm going to go in through the steps. If it were negative, I would immediately say that the answer is all real numbers, because of the greater than statement. Absolute value is always greater than a negative number. Now, since it's a greater than, it's going to be a disjunction. And step number 3 is to rewrite my two inequalities. So that's going to be 3 plus 2x greater than or equal to 13. 3 plus 2x less than or equal to negative 13. Always switch that symbol. I'm going to add the 3, subtract the 3 to both sides, solving these simultaneously, and I get 2x greater than or equal to 10, 2x less than or equal to negative 16. Divide both sides by 2, and I get x is greater than or equal to 5, and x is less than or equal to negative 8. Now, because it's a disjunction, I will connect these with an or statement. X is greater than or equal to 5, or x is less than or equal to negative 8 is the solution. All right, next we're going to run through several more examples so you can see this practice at work, and then we'll have some practice with this moving forward from here. So using PEMDAS properly, I'm going to go ahead and move the 5 first. Subtracting 5 to both sides gives me 4 times the absolute value of x less than or equal to 2. Divide by 4, and the absolute value of x is less than or equal to 1/2. Now what I'm going to do is I'm going to observe what I have here. Less than means this is going to be an and statement. And this is a positive solution, so I do not need to employ the negative all real numbers or no solution strategy. So it's x is less than or equal to 1/2, and x is greater than or equal to negative 1/2. Now, because it's an and statement, I don't have to write it using the and, like I did above on the previous example. What I can do here is I can write it as a compound inequality. Negative 1/2 is less than or equal to x, which is less than or equal to positive 1/2, is my solution. Now, if you don't feel comfortable changing it into a compound inequality, that's no big deal. As long as you use the right word, this is also an appropriate solution statement. All right, question number 7. Using order of operations properly, I'm going to multiply both sides by 3. 2x plus 7 less than or equal to 3. I'm going to observe that this is also an and statement because that says less than. I'm also going to observe that this solution is positive, so I don't have to employ the all real numbers or no solution observation. Less than or equal to 3, and 2x plus 7 is greater than or equal to negative 3. Subtracting 7 to both sides is the appropriate way to use order of operations to solve this inequality. 2x less than or equal to negative 4, and 2x greater than or equal to negative 10. Dividing both sides by 2 gives me x is less than or equal to negative 2, and x is greater than or equal to negative 5. Now, you can write this as an and statement, as I stated earlier, or you could rewrite it as a compound inequality. Whichever one you feel more comfortable with is an appropriate solution set in this particular problem. I'm going to multiply both sides by negative 2. Multiplying both sides by negative 2 is the appropriate way to isolate the absolute value in this particular case. Now, because I multiplied by a negative number, I've got to switch my symbol, and that's going to be negative 2. Sorry, negative 6, because 3 times negative 2 is negative 6. Remember, whenever you multiply or divide by a negative number, you have to switch the inequality symbol. It's at this point that I observe that this is a negative number, and since that is a negative number, I can now employ the all real numbers or no solution strategy. The absolute value of x minus 2 is less than or equal to a negative solution. The answer to that problem is never, so the answer to this question is no solution. Now what I'm going to do is I'm going to take a look at this SAT style question, and I'm going to use a substitution style of solving this problem by going ahead and plugging this in for all of the answer choices given. So the absolute value of 2 minus 4 is less than 3. 2 minus 4 is negative 2. The absolute value of negative 2 is 2. And the answer is 2 is less than 3. Which of the following is a possible value of x? So this statement has to become true, and this one is so far the one that does that. So I'm going to go ahead and try that out for another one. I'll go ahead and skip down to the 6. 2 minus 6 is less than 3. 2 minus 6 is negative 4. Negative 4. The absolute value of negative 4 is less than 3. The absolute value of negative 4 is 4. 4 is less than 3. That's a false statement. If I went through the rest of these, I would notice that that would also be the case. I'll try it one more time for 8 just to show you how that works. But remember, if SAT style questions, you are on a time crunch, so you've got to make sure that you have a good strategy for doing this. And once you find a solution and you are reasonably confident that that solution is correct, you simply want to move on from your problem. So notice here that my pattern is continuing and my numbers are getting larger and larger. So the answer to this question is A.